So with this piecewise stuff, basically I've got a few examples, and they're similar. Some of them are similar to the ones that we just graphed today. So I think maybe thinking about those graphs that we just did and then the limits, maybe that will help make it make sense. So here's a piecewise function, x plus 2 and 3. X is less than or equal to 1, and x is greater than 1. And maybe the question here would be to figure out the limit as x approaches 1 from the left, and then the right, and then the limit itself. Sometimes they might just say what's the limit. Sometimes they might say the left and the right limit. With piecewise functions, because there's so many pieces, then showing you both sides is not a big deal. So first, the limit of f of x as x approaches 1 from the left. We sort of talked about it a little bit already. But all you do when you have a piecewise function, as long as one side says x is less than that number and x is greater than that number, the left side is the part where the less is, because that's the left side of it. You just plug in the 1 and you get 3. The right side would be the side that says greater than, because it would be to the right of that value. You plug in the 1. There's no thing to plug in, so what do you get? You still get 3. Because those are the same, that means that your full limit is 3. If those two things were different, that means what? Then it would be does not exist. Question so far? I think we already said all this, but we're just putting in our notes just to make sure that we've got it. So what's the limit as x approaches 0 from the left? Negative 3. And then what about 0 from the right? So what does that mean about 0 itself? You can put the 0 with the line through it, or it does not exist, either one is fine. So what on this one if I said, let's find the limit as x approaches 1? 1 is not the place where it's changing. So I think about where 1 would be located. And since it's not the place that it's changing, it's just a normal function, and I would just plug in the 1 in that particular piece, and that would be the answer. I don't plug it into both pieces, okay? Because that's not where it would be changing. Does that make sense? So what do you think the answer is going to be? 4? Good. Because 1 is located greater than 0, and so I just plug it into that one, and I get 4. What if I had the limit as x approaches negative 2? Do that one. I threw that one in there just so y'all could practice with those negatives. So we have negative 2 squared minus 3. What do you think? Negative 7. Any questions? All right. Now let's get to the strange ones. On that one sheet that you're going to be working on, most of them are like those first two examples. So this time I'm interested in the limit as x approaches 2. I'm not going to ask you left, right, and all that stuff. But in order to find it, I have to think about the left and the right. Do you agree? Is any part easier than another part? Where would you start? I would start trying to plug in 2's. Because it says x approaches 2. 2 is the place that it changes. So that's what I would start with. I would start to plug in a 2 on both of them. Now the top one doesn't seem like it's going to work the way I want it to, so I'm just going to hold on from that one just a second. I can plug it into the second one pretty easily. A third times 2 is 2/3. 2/3 minus a third is 1/3. So I know I'm going to get 1/3 here. That's 2 from the right. The question is, what do I get up there? So if it's a problem like that where you can't just plug in a 2, it could mean that there's a hole. It could mean that there's an asymptote. Most likely it's a hole. Okay? So what I want to do is I just want to rewrite that, maybe factor it and simplify it, and then try to plug it in if I can. Okay? So if I take x minus 2 and then factor the bottom, what would the bottom factor out to? X minus 2x plus 1. Alright, so those would go away, and then I have 1 over x plus 1. So this equation is technically the same as this equation, except there was a hole at 2, because when it crosses out, that means there was a hole. Those two equations are essentially the same, except for at that one point. Okay. The y value, though, that the graph would be approaching would be whatever, when you plug it in, that you would get from this, because that's where the hole would be located. Okay. So I plug into 2 into that. What do you get? Once I plug into 2 there, I get 1/3 for that one. So what does that mean about the limit as you approach 2? 1/3. So it might not be quite as easy as just plugging it into both of them. You might have to do something, factoring it and simplifying a little bit before you plug it in. Questions on that one? Okay. I want you to try this one once you get it written down. What happens on it? Yeah, you get -2 when you plug in 0. On the first part, you have to factor the top, right? And I threw that one out there just because it's the difference of 2 squares, and sometimes people forget that when all of it's squared, even the 9, that you can factor that. But that's 3x minus 2, 3x plus 2 on top. Those cancel, plug in the 0, so on that one you get 2. Which means that this limit does not exist. Questions? Okay. Almost done with Piecewise, and I can show you the new thing, which is really fun. I like it. So all the other ones have said x is greater than 0 or less than 0 or whatever, but this one is the one that has the equal mark. Now think about those graphs that we just kind of drew. The times that it just said equal or not equal, what happened on those graphs? It was just a hole, right? It was just whatever the original graph was with a hole at wherever it was located. So here there's going to be a hole at 0. So there's not really anything to do but to know that, okay, the graph's going to be a parabola, except at 0 the value is going to be 4. The point will be. Okay? So you don't have to graph it, but if it helps you to think about it, then do that. Okay? What do you think the limit's going to be as you approach 0? So it's saying it's a parabola. The parabola would look like this, right? And then the 4, there would be a point up there.
Does not exist. 0.
I heard 4, I heard does not exist, and I finally heard 0. I think it's 0 here. Because on the left side it's approaching 0, on the right side it's approaching 0. That point really doesn't affect anything. It's a whole big problem to really just ask you what the limit is of x squared as you approach 0. Kind of silly, I understand, but something you need to know. So really, I didn't even care about that 4. Really, I just had to plug a 0 into the first thing. because remember, when there's a hole, the limits still exist at the hole. Okay. All right, one more, and then we're done with piecewise. We'll give you a second to think about this one before I just explain it. So I could have x minus 2 over x times x minus 2, which is 1 over x. Now I could plug in the 2. I get a half. That would be the limit, regardless of the fact that there's a negative 1/2. Now, what we'll be talking about next week is something called being continuous and discontinuous. And although the limit does exist, this particular graph is discontinuous because the whole is not the same value as what the limit is. Does that make sense? If this were a positive 1/2 right here, then that y value would be the same, and then it would be continuous because they would connect. So limits and continuous, they sort of affect each other, but they're a little bit different. And so that's the reason for looking at it this way. We'll talk about it more when we get to the continuous, discontinuous stuff. All right, the new thing. There's this formula. And you've probably seen the formula before. Pretty sure in pre-calculus you use the formula a little bit. At this point, I will give you the formula. Later on, you have to memorize the formula, and you have to use it. Now, I'm telling you, it is a formula that relates to derivatives. So it's a very, very important formula. But at this point, I'm not going to tell you what it means or anything like that. Right now, I just want you to practice to make sure that you know how to use the formula. Okay? Later on, after this unit, we'll get to the point that we understand where the formula comes from and what it's used for and how this derivative thing relates to it. Now, I just want you to be able to use it. Okay? I want you to be able to do things with it. So, you're going to use that formula, and then it's going to tell you that f of x equals something. Okay? So I have all kinds of different equations that f of x could equal. We'll do an easy one first, and then maybe look at a hard one. Let's say that we have f of x is 4 minus 3x. And it's asking me to figure out this limit thing here. Okay? It gives me f of x, and it says that it wants me to find that limit. Okay? So whenever it gives me that formula, there's several things I need to know. Like, at first it says, well, I know I'm going to do the limit. But then it says f of x plus h. Okay? Well, f of x plus h, if it helps you to write it out before you use the formula, that just means that x plus h is plugged into the x place into whatever f of x is. Okay? So it means that you take x plus h and you plug it right there. Okay? So f of x plus h is 4 minus 3 times x plus h. Does that make sense? And after you figure out what f of x plus h is, then now you can use the formula because it says f of x plus h. Well, we know what that is. That's 4 minus 3 times x plus h. Then it says minus f of x. Well, what's f of x? 4 minus 3x. It tells me that. Be really careful. You're subtracting it, so that minus has to go to both pieces. And then all over h. So you're just using that formula. Pretty much all you're doing is plugging in f of x plus h, plugging in f of x, and then dividing it by h. Okay? So we've got two variables here. The h is sort of like that delta x thing, except it doesn't have deltas, and it looks nicer because it's an h. Okay? Alright, so now I just need to simplify. So we've got 4 minus 3x minus 3h. I'm multiplying by that 3's. And then minus 4 plus 3x, and all of that's over h. So all that stuff cancels. You've got negative 3h over h. The h is canceled, and so negative 3 is your answer. Questions about that? Honestly, in the past, the hardest part for people is just making sure they plug it in correctly. And I don't know why that's hard, but that always seems to be one of the problems. Let's do another one that maybe is a little bit more difficult. We're still going to use the same formula. I'm not going to write it down again because I think you wrote it down again. So I'm just going to change f of x. So this is number 8. And if it helps you, the first thing I would do is, if I know I'm using that formula, is I'd go ahead and figure out, okay, what's f of x plus h? So what's f of x plus h? Square root of the x plus h goes in the place of x. So x plus h plus 3. Notice that 3 is underneath the square root. For some reason, a lot of people get confused on that part too, but the 3 is underneath the square root, so you can't forget that part. Okay? Alright, see if you can write out the formula. Limit as h approaches 0, and then write out the formula. So it's f of x plus h, the green one, minus f of x, the blue one, all over h. Any questions about that? Does it look familiar? All of these problems are going to use these properties that we've been using with the algebraic stuff. There's probably going to be a conjugate one. There's probably going to be a common denominator one. There's going to be like a simplifying one, kind of like the first one. What kind is this right here if I want to find this limit? The conjugate, because it's got the square roots. It's just a strange square root. That's the only difference, okay? So if I'm going to multiply by the conjugate, it's just a bigger square root kind of thing that I'm looking at, but it's the same process. Remember that on top I'd multiply it out, on the bottom I would just leave it alone because that part isn't going to simplify with anything. So on the top, first one times the first one, that's x plus h plus 3. Remember, the outside and inside always cancel when you use the conjugate as long as you're using it correctly. So really I just want the last. And what's the last? Minus x minus 3. Alright, so the x's go away, the 3's go away. We've got an h on top and an h on bottom. Now what? Those h's go away, so we get 1 over all that stuff. And what's the very last step? What's the limit approaching? And is it x approaching 0 or h approaching 0? So this part is 0, which means you have 1 over, you can leave it as square root of x plus 3 plus square root of x plus 3, or if you wanted to simplify that is 2 square root of x plus 3.